Okay, so we talked about the union of sets. Now let's see how we can use that to help us solve a compound inequality with the word or. Now just like we did earlier, you want to solve each inequality separately or individually, and then we will try and use the union of sets to help us figure out the solution set. So you can see here we're working with the inequality with the word or. We'll go ahead and start solving each one of these. So let's start with the first one here. And you of course want to start out by getting x by itself. So subtract 1 on both sides. And you end up with x is greater than 2. And then do the same thing on the other side. Get your x by itself. Move your 4 over. You'll end up with x is less than negative 2. And of course we are using the word or to join the two solution sets. So again, looking at our graph here, we're saying x is greater than 2, not including 2. So that's going to be all the values here. Or x is less than negative 2, not including 2. So that will be all the values right over here. So when you combine these two together, we're basically saying you have your 2 here, your negative 2, your x is greater than 2, and x is less than negative 2. You can see they are two separate sets here. So to combine them, we will have to use the union of sets. And your solution set here will be this half, which is negative infinity to negative 2. Because again, that is all the values for x which will be less than negative 2. And then the other set will be everything greater than 2, which is 2 to positive infinity. And then we will use the union symbol to join these two sets, because we're saying x can be here or x can be here. So it can be in any of these two halves basically. And then we use our union to combine the two sets together. And that's how you will basically work with any compound inequality which uses the word or to join the two together. Let's look at another example here. We have 3x is less than x plus 12, or x plus 1 is greater than 10. Now again, remember, you're trying to solve for x, so you want to start out by getting x on the same side. Okay, so we'll move our x over from here. That gives me 2x is less than 12. And then I will divide both sides by 2, which will give me x is less than 6. Okay, so that takes care of the one side of our inequalities. Now let's look at the other side here. We have x plus 1 greater than 10, so we will start by moving the 1 over to the other side, which gives you x is greater than 9. So now that we have solved the two inequalities, you can see that we end up with x being less than 6 or x being greater than 9. If we look at this as a graph, when you say x is less than 6, you are saying all the values that are less than 6 right here, and not including 6, of course. When you have x greater than 9, if you look at that graphically, you will have all the values of x which will be greater than 9, not including 9. Okay, now if we try to graph these two separate x values on the same graph, this is what that graph will look like. You have all values of x less than 6, or all values of x greater than 9. So your solution set for this problem is going to be negative infinity to 6 and 9 to positive infinity. And again, you can see we are not including the 6 and 9. And to join the two intervals, we will use the union symbol. Okay, so this concludes the section 9.1.